Hello friends, welcome to this video, and in this video we will be discussing the problem wherein we are given an array of elements and we are also given an integer value, and we are asked to find in this array pair, that is two elements whose sum is equal to this given integer. So it is the problem is very straightforward and very clear. Also we need to output those pairs. So the in this use case we have two pairs whose sum is equal to 5. One is 3 comma 2, another is 4 comma 1. We have to output these two pairs in our case. What is the solution and how to code that we'll be seeing in this video. So the solution is there are two solutions actually. One is we can use sorting technique and use two pointers to track the left side and the right side of the array, and using those two pointers we can decide on the uh, sum value, and based on the sum value we will take the decision. So we'll see that in a moment. And the other technique is hashing technique, where we use an extra temporary auxiliary space for storing our element, and using that extra auxiliary space we'll try to determine the sum and print out the pairs. So the time complexities for these two techniques is, in case of sorting and using two pointers, we have the time complexity and the space complexity depending on the sorting algorithm used actually in the technique. And in case of the hashing, the time complexity is big O of n, where n is the number of elements, and the auxiliary space complexity is also big O of n, where n is the number of elements. So first let me explain you in detail like what this sorting technique and the two pointer technique does. So basically what the sorting technique is all about is first we sort this array. Okay, so on the first step after sorting, the array becomes like this. So the elements in this array are now sorted, so it is 1 2 3 4 5. We then take two pointers, one is the left pointer and one is the right pointer, and we'll point it to the first element. The left pointer is pointing to the first element and the right pointer is pointing to the last element. Then we will add these two values. Okay, so when we add these two values we are going to get 5 plus 1, which is 6. Okay, so when we add these two elements 1 and 5, we get a value of 6. Okay, then we compare this 6 value with whatever the given integer value is. In our case it is 5. Now we see that 6 is greater than 5. Okay, so when we see that 6 is greater than 5, what we have to do is, from our sum we need to reduce something, right? In fact, we have to add to the left portion something which is lesser than whatever we have taken from the right side, right? So for doing that we will decrement this right pointer. Okay, now then we will keep this left pointer in place. Wherever it was, it will be there only. Now we will again do the sum. We'll check 1 plus 4 now. Okay, so after checking 1 plus 4, what do we get? We get 5. So we'll check 5 whether it is equivalent to the given sum, which is 5. Okay, so it's equivalent to the given sum. Then we will simply print out this 4 comma 1 pair, and then we continue like this. Then since we found a match, we increment both the pointers simultaneously. Okay, so the left pointer is incremented to the second index, sorry, the index number 1, and the right pointer is incremented to the index number 2. Okay, so now then we again add 2 plus 3, so we get 5. Okay, now we are getting 5, so we print out that pair as well. So we print out that pair as well, and finally we increment both the pointers, right? So now both the pointers are equal. So when they are equal, we exit the loop. So that is the whole logic behind the sorting and the two pointers technique. Now let's talk about the second technique, which is hashing. So in hashing, what do we do is we take this extra temporary array, okay, or a list or a set, whatever it is. So we take this extra temporary. Idea behind this is nothing but you have the sum as 5. Okay, now you will iterate this entire array and you will pick up each element and you will subtract it from the sum. Okay, so and if you, whatever the result you will get after subtracting each, so let's say you are subtracted the 3 from 5, the result is 2. If that 2 is already existing in this temporary space we created, we say the sum exists, I mean the pair exists, and we print out that pair. If it doesn't exist, we continue subtracting the rest of the elements. So how, let me just uh, demonstrate you the example. So first, I'm getting this element 3 right in my array. So what I'll do is I will first do the subtraction operation 5 minus 3, which is nothing but 2. I will check whether this 2 exists in this array. Okay, it's not there. Then it's, since it's not there, I am adding 3 to this array. Okay, then I'll move on to the element number 1, and I will do the same thing again, 5 minus 1. So 5 minus 1 is 4. I will check if this is present in this temporary array. So the element is not there in temporary array. 5 minus 1, 4. 4 is not there in this temporary array, so I add 1 as well. Then I'll come to 2. So 5 minus 2 is 3. Now I will check if it's there in temporary array, the 3. Okay, yes, we have our 3 element in the temporary array. So it means we have found a pair, right? Because 3 plus 2 is 5. So we have found a pair. I will print out that pair, and then I will move on my pointer just forward, and I will then check 5 minus 5, 0. 0 is not there in my array. Then I will move on with 4, that is the last element, and then I will check whether 5 minus 4, that is 1, is present in the array. Okay, it's present in the array, so I'll print out that pair. That simple. And the space complexity is obviously big O of n, where n is the number of elements. This is the worst case. So worst case, we might have to store all the elements. And time complexity is also big O of n, because we have to iterate over the entire array. And in the previous technique, in the sorting, the entire complexity depends upon the sorting algorithm, because first we will sort the array, so that depends upon the sorting algorithm. Now let's look at the code for both of these techniques. So first let's look at the code at hashing. So hashing, it's a very simple technique. Now I'm taking a hash set, in my case an integer hash set, and I am iterating over the entire loop, just whatever I've said previously. Then I am doing sum minus the current index element, so that will give me the other pair element. So I'll just check whether that other pair element contains is there in the temporary space we created. If it is there, I'll just print out the sum pair, and or else I'll just add that particular array element to the temporary space. Other technique is sort and two pointers method. So in that, what I will do is I will initially sort the entire array. I'm taking two pointers, left pointer and right pointer. Right pointer points to the rightmost index, left pointer points to the starting index. Then while left pointer is less than right pointer, until both the pointers meet, I'll iterate the entire loop, and I'll check if both the uh, left pointer and the right pointer index elements sum up to the value provided to us. And if they do, I'll print out them, and I will increment the left pointer and I will decrement the right pointer. And if I get the sum to be less than the given sum, I'll just increment the left pointer, and if I get the sum of the two elements greater than the specified sum, then I will decrement the right pointer. Yeah, so this is about the sort and two pointers method as well. So coming to the time complexities and space complexity, the time complexity depends upon the sorting algorithm which is used here. So in my case, the time complexity is n log n, as internally it uses dual pivot quicksort, and the complexity of that is n log n. And in the space complexity, at least it will take log n time. That is the space complexity and time complexity. Both the time complexity and the space complexity depends upon the sorting algorithm used in this technique. And coming to the hashing technique, we have the time complexity as big O of n, because we iterate over the length of the array, and the auxiliary space complexity is order of n, because in the worst case we might be ending up in storing all the elements in the temporary space. And now let's take a look at the main method as well, wherein I'm providing my array, which I have shown you previously, and I'm providing the sum value. So now let's run and see where we are getting the output as expected. So yeah, here I have my output. So with using the hashing technique, I am printing out the pair values. 2 comma 3, 2 plus 3 is 5, and yeah, 4 plus 1 is also 5. So we have printed both the pair, and using the second technique, the sort array and two pointers technique, we get the same result. So yeah, that's about the techniques used for solving this problem. And that's all for this video. Thank you for watching.